Very good evening to all. I'm Deepa from Chemistry Department. I'm working in Erode Secondary Engineering College. Today we have to discuss about estimation of hardness of water sample by EDTA method in the unit of water technology. Actually, it's a very important for chemical industry because determination of hardness present in water. So it is a complexometric method. It is more accurate and convenient and fast method. So it is widely used for the estimation of hardness of water sample. EDTA, that means ethylene diamine tetraacetic acid. The structure is shown in the figure. EDTA is chosen because insoluble in water and its disodium salt is soluble in water. It is used as a complexing agent. EDTA forms stable complexes with hardness producing salts. And principle of this method is EBT indicator reacts with hardness producing salts. It produces unstable complex of EBT. And also it can be titrated against with the EDTA solution. It forms the stable complex. And also EBT becomes steel blue. After adding buffer solution by maintaining the pH value of water up to 9 to 10. The buffer solution is the mixture of ammonium chloride and ammonium hydroxide. The end point is wine red to steel blue. Then there are 4 solutions are needed for this experiment. First one is standard hard water. Second one is EDTA solution. Then third one is EBT indicator. Then fourth one is buffer solutions. You have to prepare in these solutions of known concentrations. And then the procedure will be starts. First titration is standardization of EDTA solution by using standard hard water. You have to take 50 ml of standard hard water into a clean conical flask. And by adding 10 ml of buffer solution and 2 to 3 drops of eriochrome black tea indicator, the solution becomes wine red. Further, the solution is titrated against EDTA solution. The solution becomes wine red to steel blue. You have to note that the burette reading. Volume of EDTA is consumed to be a V1 ml. Then the calculation is 1 ml of EDTA is equal to 50 by V1 milligrams of calcium carbonate. Then second iteration is estimation of total hardness of water sample by using standard EDTA solution. This is also same procedure. You have to take 50 ml of sample water into a clean conical flask and then by adding 10 ml of buffer solution and also 2 to 3 drops of EBT indicator, the solution becomes wine red color. After then it can be titrated against EDTA solution. The solution becomes steel blue. The burette reading is noted. The volume of EDTA is consumed to be a V2 ml. Then we have to calculate the total hardness of water sample. That is equal to 1000 V2 divided by V1 ppm. Then third iteration is estimation of permanent hardness of water sample by using standard EDTA solution. You have to prepare a boiled water. That means the sample water is boiled for 10 to 20 minutes. The temporary hardness can be removed. So the water contains only permanent hardness. The boiled hard water is taken into a small clean conical flask. And then you have to adding 2 to 3 drops of indicator followed by the ammonia buffer solution. The solution becomes wine red. It is also further titrated against EDTA solution. The solution becomes steel blue. The volume of burette solution is noted. It is considered to be a V3 ml. Then the calculation is to find out the permanent hardness, that is equal to 1000 V3 divided by V1 ppm. Then total hardness minus permanent hardness is the temporary hardness. The calculation is 1000 by V1 into V2 minus V3 ppm. This is the estimation of hardness of water sample by using EDTA method. Then the next topic is boiler troubles. First of all, The boiler, that means it is an instrument or an equipment used to boil the water. That means the water is converted into steam by using an instrument. The instrument is known as boiler. Boiler feed water, that means the water is feed into the boiler for the production of steam, is known as boiler feed water. If the water is containing hardness, that means it produces some troubles. The troubles name is sludges and scales, then boiler corrosion, plastic embrittlement, priming and foaming. First one, scale. Scale, that means it is a formation of scale, and sludges is due to the formation of inner walls of the boilers. Scale, that means the precipitate is hard and adhering on the inner walls of the boilers. It cannot be removed easily. Sludges, that means the precipitate is loose and slimy. It can be removed easily. Is the difference between these two, sludges and scales? Sludge is a loose and slimy precipitate. Scale is a hard and adherent coating. Sludge can be removed easily. Scale cannot be removed easily. Sludge is a poor conductors of heat. Then scale act as a thermal insulators. Sludge decreases the efficiency of boiler, and scale is also decreases the efficiency of boiler and becomes boiler explosion. Sludge can be removed by scraping with a wire brush, but scales can be removed by giving thermal shocks, scraping, or any one of the hot method. Then scale, wastage of fuel in large scale. Then scales, that means fuels can be wasted. Then the next topic is softening or conditioning process. Softening, it is an experimental method, that means the process of removal of hardness producing salts from water, and it can be converted into soft water. The process is known as softening or conditioning. The hard water is converted into soft water. It is known as softening or conditioning method. There are two types of conditioning methods. First one is internal conditioning process. Second one is external conditioning process. The external conditioning process is also divided into two types. First one is ion exchange method. Second one is reverse osmosis method. The internal conditioning methods are classified into four types. First one is colloidal conditioning, second one is phosphate conditioning, third one is chalcone conditioning, and fourth one is sodium aluminate conditioning. Colloidal conditioning, that means we have to adding some boiler compounds into the boiler. You have to remove the scale forming substance. By adding organic substances, colloidal substances like kerosene, agar-agar, you have to eliminate the sludges and scales. It's known as colloidal conditioning. In second one is phosphate conditioning. In high pressure boilers, phosphate conditioning method is used. By adding phosphates can be react with calcium and magnesium salts to give soft sludges of calcium and magnesium phosphates. The phosphate conditioning method is also further classified into three types: trisodium phosphate, disodium hydrogen phosphate, sodium dihydrogen phosphate. Trisodium phosphate is used for acidic water. Disodium hydrogen phosphate is used for weakly acidic water. Sodium dihydrogen phosphate is used for alkaline water. And third one is chalcone method. Chalcone is namely sodium hexametaphosphate. By using chalcone, you have to eliminate the sludges and scales. In fourth one is sodium aluminate conditioning. You have to adding sodium aluminate chemical into the boiler. You have to remove the sludges and scales from boilers. So these are the internal conditioning methods. Then there are two types of external conditioning method. First one is demineralization or ion exchange process. So ion exchange process, that means this process removes almost all anions and cations present in hard water. So only the method is known as demineralization process or deionization process. Here soft water is not a demineralized water. but demineralized water is a soft water, because demineralized water does not contains any cations and anions, but soft water contains other cations and anions except calcium and magnesium. Cation exchanger and anion exchanger. These are the two parts of ion exchange process. First of all, hard water is passed through a cation exchanging column. Cation exchanging column contains acidic functional groups. It removes all types of cations present in water and can be represented by RH2. R represents resin, H2 represents the acidic functional groups. It absorbs almost all types of cations present in water. And cation free water is further passed through the anion exchanging column. Anion exchanging column contains basic functional groups. It removes all types of anions present in water. Finally, the water coming out from ion exchange process is free from all types of cations and also all types of anions. So only the water is a deionized water or demineralized water. The diagram of ion exchange process is shown in the figure. The advantages of this method is it is highly acidic and also alkaline water can be treated in this process, and it is used in high pressure boilers, and it produces water of very low hardness. Disadvantages is equipment is very costly and more expensive chemicals are needed. Then anion exchanging column can be regenerated by adding NaOH, and cation exchanging column can be regenerated by adding HCl. Thank you.